Hello guys, welcome back to our channel. In this video, we'll help you to determine what orbital diagrams are, and then we will discuss the orbital diagram of manganese. We know that every atom when looked at microscopic level has certain number of protons and certain number of electrons. Now orbital diagrams are just a way of representing the arrangement of electrons around nucleus in a particular atom. And in order to figure out how and where these electrons go, we follow three main rules. Let us see what they state. The first rule is Aufbau's principle that arranges orbitals in terms of their energy levels. So down here we have 1s sublevel that has one orbital, then comes 2s sublevel and so on. So the electrons will go in 1s orbital first and then move on to the orbitals having higher energy. Now the second rule is Hund's rule that explains the arrangement of electrons in an orbital of sublevel. Well, electrons tend to be as far as possible from each other so as to minimize the repulsion. So if there is a case where there are empty orbitals available in any sublevel, then instead of pairing, they will choose to be arranged separately. Now that makes sense why this arrangement is more stable than this one. The third and last rule is Paulis exclusion principle that states the arrangement of two electrons in any orbital. It states that there can be maximum of 2 electrons in an orbital and that 2 should have opposite spin. No 2 electrons with same spin can occupy a single orbital as shown here. That is incorrect. Now that we have discussed the basics that we should know for orbital diagrams, let us move ahead and draw one for manganese. Now manganese is a d block element and has an atomic number of 25. That means that it has 25 protons and 25 electrons. Now that we know the number of electrons, let us write its electron configuration. It will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. If you add up the numbers here, you will get the value of 25. Let us arrange the electrons in orbitals. S can hold maximum of 2 electrons, so we will place 2 electrons with opposite spin. Same with 2s. Next comes 2p, then 3s, 3p, 4s, and now we are still left with 5 more electrons, and based on the Hund's rule, we know how the 5 electrons will be placed in this orbital. So there you have it. This is the orbital diagram of manganese. For more such videos, make sure to subscribe our channel and thank you for watching.